Hey everyone, it's Isaac from okiko.org. Today I'm going to be telling you what composite functions are, how to use them, as well as a few example questions you might see on a test. So for functions, before we talk about composite functions, which is joining two functions together, we have to remember what a function is. A function is just like a machine, okay, that takes in an input and it produces an output for us. So if I give you this example, fx equals to x plus 3, this x here is considered the input. What the function does to that input is it takes the input of x and it adds 3 to it, just as an example. So if I were to put various different numbers instead of x as the input, it will look something along the lines of this. F of 3 would become 3 plus 3, because remember what the function does is it takes the input and it just adds 3 to it. So 3 plus 3 would be 6 in this scenario. Likewise, f of 2 in this case would be 2 plus 3, because we're taking the input 2 and we're adding 3 to it. So 2 plus 3 is 5, and that's the answer there. So what happens if you introduce another function into the question? Let's say you have gx equals to, let's go for 5x minus 2 maybe. All right, if you have a composite function that goes like this, and I'm just going to write it down here, f of g of x. This is the usual way that you will see f of g of x written. What it means is essentially you take the function f, but you take the whole body of gx, the whole function of gx, as the input for it. If you see it written like the left hand side over here, it's the same as this. Just keep that in mind, because for some of your teachers or your friends working, you may see the brackets put in, and for some, you may see the brackets left out. Just know that they mean the exact same thing. All right, the one on the right is a bit clearer. So if I follow the same trend that we saw just now, all right, f of g of x is us taking the input and adding 3 to it. So what is the input this time? Well, the input is gx. So I'm taking gx and I'm supposedly adding 3 to it. That's what we were doing with the previous functions f3 and f2. Here, we can replace gx itself with what expression it is. In that case, 5x minus 2. So swap out gx for 5x minus 2, and now you're looking at 5x minus 2 plus 3. You can add the two numbers together. Negative 2 plus 3 is positive 1, so that's a plus 1. And that is your expression for fgx. That's how you get a composite function. You are just putting another function as the input of another function. All right, or you're taking one function and putting it as the input of another. What happens if you do gfx? Some people assume that this is the same, but this is not the case. So you do have to be careful with the order in which you do this. If I say gfx instead of fgx, it's as if I'm taking the function g, but I'm putting in fx as the input of g. So what does g do to its inputs? Well, g takes its input x and then multiplies it by 5, followed by a subtraction of 2. So if that's what happens to the input x, the input fx should follow the same pattern. You take fx, multiply it by 5, and then minus 2. So the same trend happens to the input. This time the input just happens to be fx. So what you can do, and I'm going to write the equal sign a bit further back here, is you can take this 5 times fx, which is actually just x plus 3, and then minus 2. You can expand the 5 out into the bracket, so that's 5x, because 5 times x, and 5 times 3 gives you 15. Then one more step would involve this 15 minus 2 here, giving you 13. So that's the expression we get when we go for gfx instead of fgx. So as you can see, the order in which we make our composite function matters. And that's basically the gist of composite functions. So let's go ahead and take a look at some example questions that you may see on a test, and we'll run through them. Let's take a look at this first question. We have fx equals to x cubed, gx equals 5x plus 2, and the goal is to find gfx. So gfx, always remember, the first letter that you see is the main function. Whatever comes after that is just its input. So gfx is like taking the function g, but using fx itself as the input for g. So if gx up here, if you can see this underlined in blue, takes its input x, multiplies by 5, and then adds it with 2, well, then we should follow the same idea for fx. Multiply by 5 and add by 2. So I'm going to put fx here, and I'm going to times it by 5 and add 2 off to the side. 5fx plus 2. After you have this, you can replace this fx with what it actually is. We have an expression here, fx equals to x cubed. So you can just swap it out. So that gives you 5x cubed plus 2, because your fx gets swapped out for x cubed itself. And that's the expression for gfx. And this is already it. In this next question, we have two different functions, f and g, and the goal here is to find fg of 3. So fg3, it's us taking the function f and using g of 3 as an input. Now, if we don't know what g of 3 is yet, no worries, we can do that off to the side. So you can work it out separately, and that looks something like this. If I take g3, it's like I'm putting 3 into the function of g. So what does g do to its inputs? It takes its input, and then it takes 2 to the power of that input. Gx is 2 power x. So g3 should be 2 power 3. 2 power 3 is 2 cubed, so 2 times 2 times 2, that is 8. So in the end, you can just replace this back inside your main working equation. F of g of 3 is just f of 8 actually. So you can actually just swap it out straight for that, provided that you do show this working here to the side at least. F of 8 is just putting the input 8 into the function fx. So we're going to see what it does to its input. Fx, alright, multiplies its input by 3, alright, 3x, and then subtracts 5. So we'll do the same to the 8 here. We're going to take the 8, multiply by 3, and minus by 5. Same idea here. 3 times 8 is 24. And 24 minus 5 is giving us 19. That's going to be the value for fg3. So for a question like this, if you happen to have a composite function with an input other than x, you can actually take it out to the side, work on it a bit first before simplifying and putting it back in. That will make it a bit easier to work it out. Going to our last question here, let's find x when gg of x is 7. So you have gx listed there as 2x plus 3. So if you're looking at ggx equals to 7, that's not just a function or an expression, it's a whole equation, which means that we will have to find a solution for x. First, you may want to think about what ggx is. Ggx is just taking the function g, but using the function g itself as an input. So it looks like this, and we just have to check, what does g do to its inputs? Well, g takes its input x, alright, if you see up here, multiplies it by 2, and then adds it by 3. So times 2 plus 3. We're going to do the same thing to this input gx. So take that gx here, times 2 and plus 3. 2gx plus 3 is what we should get. Keep in mind that we are not just going to leave it like that because it is an equation, so you do have to copy down the equals to 7 on the right. So keep it going, alright, don't change anything from there. After that, we can replace this gx in the equation with the actual expression gx. Because we know gx is equal to 2x plus 3, go ahead and just swap that out. 2 times gx is 2 times 2x plus 3. And from here, you get an equation where you just have x to solve for. So as long as you can do some equation solving, this should be no problem. I'm just going to work it out here so you can take a look. 2 can be multiplied into this bracket. 2 times 2x is 4x. And 2 times 3 is 6. I can join the 6 and 3 together as a 9. And if I bring this over to the side here, we'll move over 9 to the right hand side. So 4x is equal to 7 minus 9. 7 minus 9 is negative 2. And finally, to divide this 4 over is the last step. So x is negative 2 divided by 4. Don't forget to simplify this. It can be very easy to leave this as the answer, but we should divide 2 on the top and bottom of this fraction. So we get on the top, negative 2 divided 2, which is negative 1. And on the bottom, 4 divided 2 is 2. So the solution for x, when ggx is equal to 7, is negative 1 over 2. And that's just another type of question you'll see when it comes to composite functions. So hopefully you found this video on composite functions helpful. If you have, then please go ahead and subscribe and like the video. It helps out the channel a lot. In the link below, you'll find a free worksheet for you to try out based on composite functions. They're questions similar to the ones that I've shown you today. The worksheet and mark scheme are both in there for your reference. So go ahead and have a look at that if you want to practice this. That's all from me for now. Thank you very much for watching, and I'll see you next time.